day. I was going to say morning, but I'm not exactly sure what time you'll be watching this. So, good day, good morning, good afternoon, good night, whatever. Today we are going to be learning our last lesson for this school year, so that's kind of exciting. And it's 10-5, factoring to solve quadratic equations. You will recall in the previous lesson that we learned how to solve quadratics by graphing, so you can graph it on the calculator and solve it that way. Not on the calculator, but you can graph it, and then you can find where it crosses the x-axis. Also, you can take the square root of both sides, but I want to be very clear that that is not possible in these cases, and when I get to example 2, I will explain more about that. But anywho, so for right now, what I want to tell you is this is all based on what we call the zero product property. So there we go, zero product property. And that property is exactly what it says. It's a product. So if you have two things that are being multiplied by each other and they're equal to 0, hence the zero product property, then either A equals 0 or B equals 0. Now that might not catch you right off the bat, but if you think about it a little bit, it makes perfect sense. We know that 0 times anything is 0. So basically what we're saying is that if you have two things being multiplied and you want to know when the product is going to equal 0, then it's basically going to happen when one of these two is 0. For example, if A is 0, then obviously it doesn't matter what B is because 0 times B will be 0. Same is true if B is 0, it doesn't matter what A is because 0 times anything will be 0. So we use that property, and I want to remind you that it is the zero product property, so it can't be A times B equals 1 or equals 10 or equals 12. It has to equal 0 in order for this to work. So the way that we solve these quadratics are we factor them. So the first one that I'm going to show you is actually really easy because it's already factored. So I have my two factors here. So the work here or the steps involved are not for you to FOIL it. That would be bad. Well, not bad, but it would just be redundant. So we don't want to FOIL this. We actually want to consider this like our product here. We know that we have an A times a B. So if we just pretend for a moment that this is A and this factor is B, then we have something that fits the zero product property. It's like A times B and it's equal to 0. And according to the property, we can then say that either A is going to equal 0 or B is going to equal 0. So we can actually solve the two factors separately. So we'll say either x plus 5 equals 0 or 2x minus 6 equals 0. And now it's not very hard to solve these at all because these are very linear, very easy to solve. We subtract 5 from both sides and x will equal negative 5. And we know that if we plug negative 5 into the original equation to check the answer, negative 5 plus 5 is in fact 0. And when you plug negative 5 into this, 2 times negative 5 is negative 10. Negative 10 minus 6 is going to be negative 16. But like I said before, it doesn't matter what B is because if this is 0, then 0 times negative 16 will still be 0. So you can see why that works when we separate them. So we know that one of the solutions is x equals negative 5. The other solution, we're going to add 6. Add 6. And we get 2x equals 6. Then we can divide by 2. And x equals 3. And again, just to show you how this works, x equals 3. If we plug 3 into the first factor, 3 plus 5 is 8. That's not 0. That's 8. If we plug 3 into this guy, 2 times 3 is 6, and 6 minus 6 is 0. But even though the first factor is not 0, when I multiply it by the second factor, which is 0, then I'll still get 0. So that's how that works. So factoring to solve quadratic equations requires that you take the quadratic, factor it, separate it into two separate cases, and then solve them separately. And those will be your solutions. So in this case, our answers are negative 5 and 3. So you are going to try a few on your own. Again, they're already factored for you. All you have to do is now separate them to the two cases and solve for each answer individually. So my next example is one where, again, it's still equal to 0, and that's important. It has to equal 0. And And now we have a trinomial quadratic here, and that's where I wanted to go back to what I was saying earlier. Some of you might be thinking, or you might try to, add 48 to the other side, or something weird like that, because that's kind of what we were doing in 10.4. We were taking the constant term and moving it to the other side, dividing by whatever was in front of the x squared, and we square rooted both sides. But let me tell you that there's a difference between something like x squared minus 48. You could even have a 3 here if you wanted to. You could add the 48, and you could divide by 3, and then you get your two answers because you'd have plus or minus whatever. I want to just kind of briefly emphasize that this problem is different in that it has a middle term. Because of that middle term, you cannot solve it this way. You can't add the 48 to the other side in hopes that somehow it's going to work itself out. It won't. So the only way to solve a quadratic that has a trinomial like this at this point is to factor. So we're going to factor this, and I'm hoping that you will still remember how to factor. So we have 1 and 1. 1 times 1 is 1x squared. And then for 48, we need, 12 and maybe 4. I think 12 times 4 is 48. And we want a negative 8 middle term. So I will make this a negative 12. And so when I add the diagonals, I'll get 1 times 4 is 4. 1 times negative 12 is negative 12, and 4 minus 12 is in fact negative 8. So the factorization works, and so I'll factor it, and it'll become x minus 12 times x plus 4 equal to 0. And now, like we did in the previous example, we're just going to take each factor separately and solve it individually. So either x minus 12 equals 0, or x plus 4 equals 0. And in this case, I add 12 to the other side. And so x equals 12 is one of my solutions. And over here, I subtract 4 from both sides. And x equals negative 4 is my second solution. So in this case, you have to factor first, and then you can proceed like the first example. So now you can try this one. And then I'll show you one last example, which is this guy. And I mentioned earlier that in order for the zero product property to work, we have to have the quadratic equal to 0. And so the first thing that you should notice about this problem is that it's not equal to 0. That's bad. So what we have to do is make it equal 0 by moving the 88 to the other side. And then we will have 2x squared minus 5x minus 88 equal to 0, because we can't combine a term with x in it with a term that has no x in it. So then we have this quadratic, and now it's equal to 0, and now we can proceed as usual, which is to factor it. All right, so we're going to try that here. The factors of 2 are 1 and 2, or 2 and 1, whatevs. And then 88, I think I'm going to try 11 and 8 and see what happens there. Make this negative maybe. So 2 times negative 8 is negative 16. And 1 times 11 is 11. So negative 16 plus 11 is negative 5. And that's what we wanted for the middle term, negative 5. So the factorization works. So now I factor it, and it will be 2x plus 11, and then x minus 8 equal to 0. And then we will separate the two factors and solve them individually. So we have 2x plus 11 equals 0, or x minus 8 equals 0. Okay? So in this case, I'm going to subtract 11 from both sides to solve. And I get 2x equals negative 11. Then we divide by 2. And we get that x equals negative 11 halves. And yes, it's okay to have fractions as answers. So we get negative 11 halves. And in this case, we're just going to add 8 to both sides. And we get that x equals positive 8. So those are our two solutions, 8 and negative 11 halves. So now you can try this last example, Remember to move the negative 36 to the other side first, and then you can factor it and solve for your two solutions. Once you've done that, you will have completed the lesson for today, and I will see you in class. Thank you.